Assalamualaikum and hello everyone. Today I would like to present to you guys about soap. But let me introduce myself first. My name is Nurul Naziha binti Nurhaizul and my ID student is 2023 at 67936. Now, let's get started. Wait. Before I start my presentation, let's see overview of my slide presentation today. So first, we have introduction. Second is element, and then analysis, structure, soap preparation, cleansing action, and the last one is additives. Let's start with introduction. What is soap? Soap is cleaning and emulsifying agent made usually by action of alkali on fat or fatty acids and consisting essentially of sodium or potassium salt of such acid. Next is element in soap. Like you see, in soap we have two elements, that is sodium hydroxide and potassium hydroxide. Now, let's check this out about these two chemicals. Now, let's begin with sodium hydroxide first. Sodium hydroxide is an alkali metal having the chemical formula NaOH. This chemical was highly soluble in water, so mainly we use this chemical to make a bar soap. So now, let's see potassium hydroxide. So potassium hydroxide is an alkali metal having the chemical formula KOH. This element less soluble in water, so typically used to make a liquid soap. Now, let's begin with sodium hydroxide first. Sodium hydroxide is an alkali metal having the chemical formula NaOH. This chemical was highly soluble in water, so mainly we use this chemical to make a bar soap. So now, let's see potassium hydroxide. So potassium hydroxide is an alkali metal having the chemical formula KOH. This element less soluble in water, so typically used to make a liquid soap. Like you see, I have example image of sodium hydroxide and potassium hydroxide. So here you can see the difference of sodium hydroxide and potassium hydroxide. For sodium hydroxide, condition is more to powder, but potassium hydroxide is more to snippets of piece. So next is structure formula. For sodium hydroxide, we have NaOH. So Na is for sodium, O for oxygen, and H is for hydrogen. While potassium, we have KOH. So K is for potassium, O is oxygen, and H is hydrogen. Now we go through to soap preparation. In soap preparation, the potassium hydroxide and sodium hydroxide will combine with triglycerides. Triglyceride is element in fat or oil. This combination will make a glycerol plus soap. This process was called as saponification. So, what is saponification? Saponification is the process in which triglycerides are combined with a strong base to form fatty acid metal salts during the soap making process. The distribution of unsaturated and saturated fatty acid determines the hardness, aroma, cleansing, leather, and moisturizing abilities of soap. Now, let's see how cleaning action of soap. Before that, let's see soap molecule. As you can see, the soap molecule have a head and a tail. So a head, we have a hydrophilic, while the tail we have a hydrophobic. So hydrophilic is a water attracting, while the hydrophobic is water repelling. Now, let's see this molecular action in cleansing. When soap is dissolved in water, its hydrophobic ends attach themselves to the dirt and remove it from the skin. Then, the molecules of soap arrange themselves in micellar formation and trap the dirt at center of the cluster. These micellars remain suspended in the water. Now, let me explain it step by step. First, if you add soap into water, we reduce the surface tension of water. Next, the soap will ionize in water to produce free-moving soap anions. So, hydrophilic parts of soap anions will dissolve in water, while hydrophobic parts will dissolve in grease. The hydrophilic part of soap anions will surround the grease. Grease will break into a small droplet. The small droplet will not reattach to the surface of the skin due to the repulsion of negative charge of the hydrophilic part on the surface of the grease. Last one, the droplets are suspended in water, forming an emulsion. When you rinsing it with water, it becomes clean because the grease droplets are left in the water. We add the last but not least part is additive. Here is some example of additive in soap. So here we have antibacterial, anti-suspicion agent, antioxidant, moisturizer, foam booster, enzymes, and fragrance. So let's check this out true by true. First, antibacterial. Antibacterial function is to reducing or preventing bacterial infection. The example is we have triclosan and trichlorocarbon. Next is anti-suspension agent to prevent soil and dirt particles from being redeposited onto surface during cleaning process. The example is CMC. Now, for antioxidant is to suppress lipid oxidation in oil used as feedstock during soap production. The example is butylated hydroxytoluene (BHT). Now, moisturizer. Moisturizer function is to improve skin hydration and increase stratum corneum water content. The example is hyaluronic acid and glycerin. Next, foam booster is to reducing surface tension to make it easier to form bubble. Example is sodium laurate sulfate and sodium lauryl sulfate. Now, enzyme to provide a higher degree of stain removal and whiteness in cleaning performance. The example is prothesis. Last one is fragrance. This to enhance the fragrance of the soup and skin. Example is lavender and sakura. So this is some research that I searched to get the information for doing this slide. The end. Thank you for watching this video and bye.